Hi grade 12s and welcome to this video. In this video, we have this question which says that given the quadratic sequence and we have the sequence, as you can see, P and Q are missing and unknown values that we have. And they tell us to calculate the values of P and Q if the second constant difference is 2. So this video is being made as a response to one of my subscribers' comment, which says, let's say they wanted us to find the value of P and Q without including 2. How are we going to work that out? So thank you to Isaac Maepa for suggesting this. And in this video, we're going to work this out. So in this case, since the constant difference is already 2, like I've already shown you in the actual past paper that this is from, the KZN March 2020 common test, you would simply just find the first difference. So we're going to just say 5 minus P, which is 5 minus P, and then of course Q minus 5, and 19 minus Q. And by the time we get it to this point, we can go ahead and find the second constant difference. And just like I did in that video, which you can also go back and watch, which would lead us to this. And then at this point, because we already know the second constant difference is 2, and this is the row for the second constant difference, we would know that each of these expressions would be equal to 2. But remember, they're constant, so they're also equal to each other. So the question is, can we actually work this out without this 2? Now, we cannot do that in this situation. And the reason why is because of the amount of terms they're giving you. They only gave you 4 terms. And because this is quadratic, it's not going to be possible. You see, in order for us to actually find that, this is not enough without the 2, of course. Because then you're just going to have this, and it's only 2 expressions that you have, and you've equated them, meaning we just have one equation. Okay, with 2 things missing. A pattern you will notice with simultaneous equations is this is how simultaneous equations work. You see, the equation we have right now is just Q minus 10 plus P is equal to 24 minus 2Q. And do you see that there are 2 variables in this equation that is missing? It is Q and P. This is how simultaneous equations work. If 2 variables are missing, you need 2 equations to find those missing variables. If one variable is missing, you only need 1 equation to find that missing variable. That's probably a pattern you're going to start noticing throughout grade 12. So now I'm going to show you an actual example with a quadratic sequence where we can actually find the missing values of, let's say, x and z without them telling us the second constant difference. And here's the example. So in this example, look at what we have. We have x, 16, 32, 54, and y. So 5 terms in total. And that is a very important thing to look at. There are 5 terms here, but you see that in this one, there were 4 terms. Okay, so I'm increasing the number of terms so that this can actually help us to find the missing variables x and y. So we would do the usual, where we would say y minus 54, and then 54 minus 32, which is 22, and then 32 minus 16, which is 16, then 16 minus x. And that will be our first difference. Then we'll have to find the second constant difference. And we'll do that by saying the y minus 54 minus 22, and you see it's only 1 term, so you don't need brackets. Then the second one we would find by saying 22 minus 16, which gives us 6. And then the third one we would find by saying 16 minus, now you see, subtracting by more than 1 term, so you'd need brackets. It would be 16 minus x. But of course, if you distribute that, that would give you negative 16 and positive x. So minus 16 plus x. Okay, so now that we have this, I can also just clean it up. 16 minus 16 would just be x. And just to clean this one up, negative 54 minus 22 would be negative 76. Now, with this example, this one, I would say it's actually not a very perfect example, but I think it will still be able to get the idea out. So look at what just happened. Do you see that because we included 5 terms this time, in our second constant difference, we have 3 terms. So this is really how it works. If you have 5 terms in your quadratic, you will have 4 terms in your first difference and 3 terms in your second constant difference. But here, the issue was that there was 4 terms already here. So it means that in the second constant difference, we were only going to have 2 terms, which would just form one equation. One equation only helps you to find one variable. And so that's not useful. That's why they had to tell you that the second constant difference was 2. But look at this one. We have 2 things missing, meaning we need at least 2 equations to be able to solve for this. Now, I know in this one, it's quite clear. We can kind of see what the answer was. But even if this expression over here had more than just x, let's say it had 5 plus x. It's not really 5, but I'm just putting that for example's sake. If it had 5 plus x, you would still be able to solve for x and y. Because remember, 2 things are missing, so you need 2 or more equations. Now let's look at the amount of equations that we can form from this. Because we know the second constant difference is constant, so they are all equal. I'm just saying if this was a 5, right? What we could have done to solve for x and y is we could have said 5 plus x is equal to 6. That is one equation we have formed. One equation by equating these two. The second equation we could have formed from this is by saying 6 and that. So we could say 6 is equal to y minus 76. That's the second equation that we can form here. See, we already have 2 equations. It's more than enough. The third equation you could form is by saying the first and the last expression equated. So that would be the 5 plus x being equal to y minus 76. And do you see now? From this, you're going to have to pick the ones that would actually help you. Remember, there are only 2 variables missing, so you only need 2 equations. So take 2 of the equations that would best help you to solve for x and y, and you'll be able to solve for x and y. So that's the whole thing around this. The reason they had to give you the 2 was because they only gave you 4 terms, meaning in the second constant difference, you are only going to have 2 terms, which makes one equation. One equation is not enough to find 2 variables. They have to give you more terms so that you can form 2 or more equations so that you can find your 2 missing terms. Okay, so I hope that made sense. I'm not really going to solve for x and y because that's actually not the answer to 5, okay? But this is just a practical example of how that would work. I hope that answered your question. And I'll see you guys in the later videos where I post the other March papers that I've worked on.